if we look at this question, it tells us that a ball is thrown upward from the ground at a velocity of 25 meters per second. So let's write down all the things we do know and all the things we don't know yet. You always have to start by writing out your givens. What is question 1 asking here, question A?
Maximum height.
We want the maximum height, which means we're looking for which variable? Y final. Okay, so for part 1, we're looking for Y final. Y final is equal to what? Now, if we look at my givens, the fact that we don't have time cancels out a few of these formula. Okay, if we look at the actual values we have, there's only one formula there that we can actually use, and that is equation 4, right? So equation 4 tells us that VYF or VFY, whatever, squared is going to be equal to VIY squared. And what's the rest of the formula? Plus 2 AY delta Y, correct? Also known as Y final. Especially if Y initial is 0, your delta Y will just be your Y final, correct? So what can I cancel out here? So if I look at my givens here, I see that my Y final is 0. Mark it in right away. Now, what am I going to rearrange this equation for? What am I looking for here? I'm looking for my Y final.
Wait, why is your Y final 0?
My Y final is not 0. My V final is 0 because as this ball reaches its max, its velocity becomes 0 meters per second. Okay? Now, if I cancel out V final here, I'm trying to isolate my Y. How do I do that? I bring this guy over, right? And this ends up working out to a positive number because in bringing this guy over, he becomes negative, does he not? Awesome. So we get negative VIY squared, which is equal to 2AY Y final. Correct? How do I isolate Y final?
Good question.
I divide by 2AY. Do I not?
Yes.
If I do that on this side, I've got to do it on the other side. 2AY. Here we go. These cancel out. So then I'm left with my Y final being the negative of the square VI, Y, divided by 2 times gravitational acceleration, which ends up being a negative as well. So those 2 negatives are going to cancel one another out to give you that positive number. Let's work this out and then we'll stop and ask questions. Okay? So if we plug in the numbers, we've got 25 meters per second squared over 2 times negative 9.8 meters per second squared. Now, if I work this out, what do I get? Notice how the units have been incorporated throughout here. By canceling out the units that are there, you should end up with the unit of the actual variable you're looking for. So let's see. Well, the second squareds here cancel out. This meter on the bottom cancels out with the meter squared up top. Look at that. You're left with meter. 1 meter. Okay, 1 meter unit. Y final is measured in meters. So this works. Okay, that is a little proof that you've arranged this equation properly. This is why I want you to incorporate your units the whole way through. Okay, so if we work this out, what do we end up having? What does this equal? 31.88. So 31.8 meters, let's say, is your Y final. So now we take this number right here. Please stop talking. We take this number and we can actually incorporate it right here where our Y final is. And as we move to the second number in this example, we're able to actually have another variable there. Okay, now that we have the Y final variable, we can perhaps look at using a different equation to figure out the second part of this equation, which is how long does the ascent take? Okay? If we look at solving for time final, we're going to use equation 1, which is Vy final is equal to Vy initial. What's the rest of this? Plus a delta t. Now here's where we see that delta again. That delta signifies t final minus t initial. We know that t initial is 0, so let's not even bother writing it. What we're looking for here is t final. So I'm going to just scratch this out, and I'm going to write t final in this case. Okay? This is not always the case, but here it is. Okay, so AY, there we go. We know that this is 0. So this is a pretty easy plug, guys. If you sit there and you bring this over, right, it's going to give you your negative VIY divided by AY is going to be equal to your time final. This ends up working out beautifully. Why?
Because AY is negative.
Because AY is negative. And you cannot have negative time. So if you were to decide, if you are a glutton for punishment and love that quadratic equation, go for it. You would get probably 2 values because the quadratic formula is plus or minus whatever, I don't remember. You will always get 2 values. If you're looking for time, that's the only reason you'd use the quadratic, you're going to take the positive time because negative time does not exist. Right? Okay. Well, no. So if you use the quadratic, what I'm saying is, if you use the quadratic equation, let me find it. So if you have this equation here, you're going to work it out where in one instance, you're going to add this. Okay, you're going to add this. And in one instance, you're going to subtract that. So you're going to get a positive number and a negative number. So you cannot use the negative number. Why do this? Why do all that extra work, especially when you're a group that doesn't like to show your work? Why do all this extra work when you can just take a much shorter equation? Okay, a much simpler equation. So think about that when you're doing this, especially when you're crunched for time. And some of you are on these tests. Okay? So if we plug this in, what do we get?
Negative 25.
Negative 25 meters per second over negative 9.8 meters per second squared. Oh, look at these units. Meters cancel out. This second cancels out, and I'm left with seconds. That's what I want. Okay? So T final ends up being 2.55 seconds, right? Now, if we look at the next question they ask us, we could work this out mathematically or we could work it out intuitively. And this one, I will be okay with an intuitive answer. Then C says, how long does the ball remain in the air? So if you think about that, the classic, what goes up must come down, exists, right? So if you know that it takes 2.55 seconds to get to its maximum height. What do you know about how long it will take it to reach the ground again?
Same amount of time.
It's the exact same amount of time. Okay? Does that make sense?
Is that just like something you always have to remember?
Well, put it this way. If I launch something up in the air and it takes 10 seconds to get to that max height, it's not going to take 15 seconds or 8 seconds for it to come back down. Its mass doesn't change. Its shape doesn't change.
No air resistance.
Even if there is, there's the same air resistance going up as there is coming down. So time does not change. Okay? So you would just double the time. But you need to show me that you're doing that. And that will pop up.